Alright guys, so given that phi is equal to x squared y z cubed plus xy squared z squared, find the gradient of phi at the given point 1, 3, 2. Alright, now we understand that our phi here is a scalar field or a scalar function. And we all know that the gradient of a scalar function is a vector function which points to the direction of the highest increase or change of what? The scalar function. Alright, so now the gradient of a scalar field or function is given as what? Change in the function, which here is what? Phi. And of course, this is phi of what? X, y, z. Now, where our change here is given as what? I die x plus g die y plus k die z. Now, we multiply this with our given function here. We're going to have what? That our this change of phi here is going to be given as what? I die x plus g die y plus k die z. Now we're going to dot this with what? The function phi here, which is what? We'll have x squared y z cube plus what? X y square z square. Now this is going to be the same thing as what? Alright, we'll have I die x of what? X square y z cube plus x y square z square plus our g die y of this same phi here, which is what? X square y z cube plus x y square z square, and plus k die z of the same phi function, which is x square y z cube plus x y square z square. Alright, now what this means here is that we're going to be differentiating with respect to x. We differentiate this we differentiate the function phi with respect to x. We differentiate function g with respect to y, and then k with respect to what? Z. Alright, so we differentiate the function phi here with respect to x. We differentiate function phi with respect to y, and function phi with respect to z. Now this can also be written in this form: die phi x of I plus what? G die phi die y plus k die phi die z. So now this whole thing here is the same thing as what we've expanded to this point here. Alright, now let's start our differentiation. This is partial differentiation. So starting with x, let's write our I outside. Now we differentiate everything here with respect to what? X alone. So whichever one doesn't have x, we keep it a constant, and whichever variable stands alone and is not x is automatically 0. So from here now, when you differentiate x squared, you have 2x. Multiply 2x by everything that's here, because everything here remains constant. We'll have what? We'll have 2x y z cube. Differentiate x from this side, you're going to have what? Plus what? Y z. Alright, y square z square. Now we've gotten that for I. Plus, now for g, this is, where is g? Alright, this is g. So differentiate everything here with respect to what? Y. Differentiate the phi function here with respect to y. So here we'll only choose to differentiate y. Here we get 1. 1 multiplied by x square z cube will give us x square z cube. You differentiate y here, you get 2. 2y multiplied by x z square will give it 2x z squared. Now we're coming down to our k. Okay, differentiate this here with respect to z. Differentiate the phi function here with respect to z. You have what? Differentiate z cube, you have 3z squared. Multiply 3z squared by x square y, you have 3x square y z cube. Z squared rather, sorry. Alright, so you differentiate z square here also with, you differentiate z square here, you have 2z. Now 2z multiplied by xy square gives you 2xy square z. Alright, now this is k. Okay, so now the next thing we're going to be doing here is to substitute in our values for x, y, z. Remember, they said at what? At point what? 1, 3, 2. Now what this simply means is that the first one here is what? X. So x is 1. Wherever you see x, you impute 1. The second one here is for y. Wherever you see y, you impute 3. And the last one is for z. Wherever you see z, you impute what? 2. Now let us substitute here. You have 2 dots. So I'm using dots for times. That means 2 times x. X here is 1. So 2 dot 1 dot y. Y there is 3. So dot 3 dot z. Z square. Z cube. Z cube. Z here is 2. So this is going to be what? 2 cube. Plus y here is 1. 3. So we have what? Y square will be what? 3 squared. Dot z square here is going to be what? 2z. 2 squared. Sorry. Now we're done. So plus what? For g, we have x squared here. Our x here is 1. So this is 1 squared. Dot z squared. Z cube. Our z here is 2. So 2 cube. Plus 2. Dot our x is 1. So write 1. Our y here is 3. So what? Dot 3. And our z squared, z here is 2, so dot 2 squared. Now plus r k. Alright, for k here we'll have x 3x squared. Our x, okay, we'll have 3 dot x is 1, so 1 squared. We'll have y here to be 3, so we'll have dot 3 dot z squared. Z here is what? 2, so we'll have 2 squared plus 2 dot what? X is 1, we'll write 1. And y dot y square, y is what? 3, so that is 3 squared. And dot what? Z is what? 2, so we write 2. Now we expand this. Okay, so all right, so 2 times, okay, let's start with this. 2 times 1 is 2, 2 times 2 is 6. All right, 6 times we're going to have I into what? 6 dot what? 2 cube here is 8. 6 dot 8 plus what? 3 squared is 9. 9 dot what? 4 for I. Plus for j here we have, all right, 1 squared is 1. 2 cube is 8. 8 dot 1 is still 8, so write 8 plus 2 dot 1 dot 3. This is going to give us 6. 4 squared is 2 squared is 4. 6 times 4 will give you 24. 24. Now for k here we have what? 3 times 1 squared is 1. So 3 times 1. 3 is 9. Now we have 4 here. So we have what? 9 dot 1 4 plus what do we have here? 2 dot 1 is what? 2. 3 squared is 9. 9 times 2 is 8. 8 times, all right, 9 times 2 is 18. 18 times 2 is what? 36. So simplifying further here, we have that 6 times 8 here will give us 6 times 8 will give us 48. 48 plus 9 times 4 should be 36. What should be is 36. This is I, and we'll have all right, okay, so this is simply 8 plus 24, and then plus k. This is simply 9 times 4 is what? 36 plus 36. So expanding everything here, we'll have 48 plus 36. That should give us, okay, that is 84. So this is simply 84i plus 24 plus 8. That is going to be, that is 32. So this is 32j plus 36. 36 will give us 72 plus 72k. So now this becomes a what? This is a vector field and no longer a scalar because of the position vectors I, j, k here. So this is telling us what? The position. Okay, thank you guys. Do well to subscribe to my YouTube channel. See you in our next class.